Okay. Then 224, mineral resources and mineral processing. Taught by Professor from Naadi Usman. The course content is as follows. We have metal and non-metallic resources, composition, distribution, and utilization, fossil fuels, surface and underground water environment, and then introduce the principle of mineral processing, combination, and concentration. These are the slides, the topic. We'll start, of course, with the definition of terms. One, we start with ore. What is an ore? Refers to the mineral resources that can be exploited at any condition profitably. Or in other words, an oil defined as a mineral that can be exploited with economic benefits. And what is a mineral? Mineral is generally defined as a natural occurring homogeneous inorganic substances having distinctive physical properties, usually of a regular molecular structure and a more or less definite chemistry. Tenor is the metal content of an ore, whose lower limit depends upon economic production. It varies from type of metals and cost of production and price of metal. It does not have upper limit. Now, resource is something that can be used to help achieve an aim, or it may also be said to be a resource from which benefit is produced. Resources are useful or valuable possessions of qualified of country, organization, or person. Hence, human, mineral, water, and energy are resources which benefit can be derived. And mineral resources means that it's any rock, mineral, or element that has a physical or chemical property found useful to human being. In other words, it's a deposit that are feasible to mine using existing technology. That is the deposit currently economical to mine or extract. So mineral reserve is a deposit that is economically to extract under current conditions. All deposits and economy occurrence of minerals that can be extracted at a profit under the existing technical and economic conditions. Country rocks, sometimes referred to as host rock or barren rock, is a rock in which the deposit is enclosed. Basically, general classification of mineral resources based on the raw materials. Minerals are classified mostly as metallic or base metal or polymetal. Examples of metallic are metallic minerals include bauxite, aluminium, cassiterite, which is also known as tin, galena, lead, lignite, siderite, and sphalerite. Non-metallic and industrial minerals and construction materials. Examples are those non-metal and industrial minerals are asbestos, barite, bauxite, manganite, clay, diatomite, feldspar, phosphide, and fluoride, and garnet. Glass sand, gypsum, graphite, kaolin, kaolite, laterite, limestone, marble, dolomite, phosphide, quartz salt, talc, and zircon, gypsum, etc. For fossil fuels, we talk about bitumen, coal, lignite, and hydrocarbon. And for precious metals, rare metals, we talk of gold, silver, platinum, diamond, and another very important class of minerals is gemstone, which includes sapphire, topaz, tourmaline, beryl, amethyst, garnet, and the major criteria for this material depends on its content and its common value. For mineral based as raw materials, it's classified based on iron and ferrometals, iron, which includes iron, chromite, cobalt, magnesium, molybdenum, nickel, lithium, tantalum, titanium, tungsten, and vanadium. The non-ferrous metals are aluminum, antimony acid, bauxite, uranium, bismuth, cadmium, copper, gallium, lead, lithium, mercury, rare earth minerals like selenium, thorium, and tin, zinc. The precious metals are the platinum group metals, which are the palladium, platinum, rhodium, and silver. Industrial minerals, like I said, asbestos, barite, bentonite, thorium minerals, diamond, gemstone industry, diatomite, phosphorite, gas, gypsum, and andesite. For kaolin, which is also known as chelicate, magnesite, phosphide, potassium, salt, sulfur, talc, potassium, salt, talc, and the rest. Mineral fuels are steam, coal, starting from the anthracite, which is the highest, is subcutaneous coal, cooking oil, natural gas, crude petroleum, oil sand, oil shares, and oil. We have minerals classified based on mineral commodities, like the base metals, usually the source of number of product metals, example copper, lead, zinc. Then the precious metals, the silver, gold, considered for monetary metals and prices are controlled or manipulated by the government. They represent well silver, gold, platinum groups. And the ferrous metals like the iron and steel are fundamental metals of every modern industrial country in the world. Example, magnesium, chromium, mercury, cobalt, molybdenum, titanium, tungsten, palladium, silicon. The light metals, in the age of energy conservation, aerospace, light metals have achieved a prominent place in our industrial society. These metals are relatively new in their industrial application, having been isolated in elemental form less than 200 years ago. Example like titanium, aluminum, magnesium, and beryllium. Construction materials, for the most part of these are the industrial minerals. They are high in volume, low unit value materials that are usually mined and consumed locally, for example, sand and gravel. Agricultural commodities, agricultural minerals or first fertilizers are bulk commodities with worldwide trade pattern, e.g. potash, phosphorus, nitrogen. No living organism can exist without phosphorus, potassium, and nitrogen. Phosphorus must be present in adequate amount in living cells for cell division to take place. Byproduct commodities, these metals are produced as byproduct of major commodities and therefore their production are supplied to do necessarily reflect demand. For example, gallium, selenium, germanium, and indium. Advanced materials, those materials developed over the last 30 years or so, being developed at the present due to their greater strength, higher strength density ratio, greater hardness, and or one or most superior thermal characteristics. Chemical properties when compared to traditional properties. Heat resistance, wear resistance, or corrosion. Examples are aluminum, zirconium, plutonium, and thorium. Then the low density and greater strength, aluminum alloys, amorphous alloys, magnetic alloys. Then the strong light, more heat resistance are the fibers of carbon, and then aluminum, silicas, and polymers. Classification based on mineralogy perspective. For the second week, minerals are classified in several ways in their structures and physical properties. One method is based on chemical composition, in which minerals are divided into classes depending on the anion or anion group of examples such as native elements, sulfide, oxide, and hydroxide. Another method is based on their form for crystals or internal structure, as with the silicates, for example, single chain structure of the silicates. Now, the native elements, looking at it, and then there are the native elements are the gold. Native gold is the main source of gold, and of course, we have the camera that is plaza or alluvial deposit. Alluvial plazas and conglomerate. Principally used as monetary standard, used in various scientific instruments, metropolitan and dental appliances. And therefore, silver in the oxidized zones of ore, usually associated with small amount of copper, gold. Primary native silver is of course the eternal gold. Used for geometric, fine emulsions, plating, tablewares, electronic equipment. Other metals which occur in the native strata are iron, lead, and platinum. The third group is the sulfur, often contaminated with clay and arsenic, bitumen. It occurs in areas of recent volcanic activities around hot spring, through dissociation and with partial oxidation of sulfide, for example, marcasite. And the most important economic occurrence of sulfur is, however, through bacterial reduction of sulfur from circulating water through the reduction of gypsum and androgen layers from organic compounds, such as petroleum used in the manufacture of hydrogen sulfur. Also used in fertilizer, insecticides, explosive, coal products, preparation of wood pulp, or paper manufacture and organization. Diamond, which is C, primary source of diamond are pipes, old volcanic rock filled with kimberlite or traumatic igneous breccia, blue ground, which forms pipe blocks. Kimberlite atolls from diamond can be washed out with the overlying heavy material, also occurred in the derived form from the primary source. Fragments of diamond are used to cut glass. The fine are used in grinding and polishing diamond and other gemstones. Wheels are impregnated with diamond, cotton rods, and other hard material. Steel bars are set with diamond for diamond drilling in mining work. Then the graphite. Most graphite deposits are fine products of metamorphism of deep-seated organic material, also occur in pets. Igneous rocks, nice crystalline limestone. It is used in the manufacture of refractory crucible for the steel brass and bronze industry. Mixed with oil. It is used as a lubricant and mixed with fire clay. It forms lead of pencils, also employed in manufacture of protective pen for structural steel and used in foundry fencing, batteries, electrics, generator brasses, and electronics. Other metals which occur in the native as arsenic, antimony, and destiny. Then the classification based on sulfide, which is the second one on sulfide. There are the pyrite. Pyrite is the most widely spread sulfide mineral. It is an accessory mineral in igneous rock, but is more often secondary. Also occurs in oil vein by contact metamorphism in anaerobic sediments And due to magnetic segregation, it is primarily used as raw material for the preparation of sulfuric acid. The second is chalcopyrite, mostly widely occurring copper mineral, mainly occur as hydrothermal vents and replacement deposits. Also occurs as small crystals associated with galena, sphalerite, and dolomite, and as an original constituent of igneous rock in mortally dyes in contact metamorphic discipline, used principally for commercial source of copper. Galena, it occurs in hydrothermal vents associated with other sulfide, dolomite, calcite quartz, barite fluoride, also found in replacement bodies in limestone, in contract metamorphic deposit in pegmatite, and as disseminated in secondary rocks, used practically the only source of lead and also an important ore of silver. Lead is used in cable lines for water pipes, in storage batteries, and in glass works as pigments. The sphalerite occurs associated with galenite, and occurrence and mode of origin are similar. Mostly used as ore of zinc. Zinc is used in galvanizing iron, making brass, and anode of copper and zinc in electronic batteries, and as sheep zinc. The others are the stibnite, the chief oil of antimony, molybdenite, the principal oil of molybdenite. And then we have the cobaltite and oil of cobalt, and the pyridite, the magnesite, and the astroferrite, principal sources of arsenic. Then classification based on highlights, rock, electronegative hydrogen ions. In that group, we have the highlight, which is the rock of sodium chloride, occurs as evaporite associated with gypsum, andesite, calcite, clay, sand, by the gradual evaporation and ultimate drying up of enclosed bodies of salt water. In this way, highlight forms as salt beds, also occurs as salt domes, vertical pipe like masses of salt that has pushed their way upward to the surface from underlying bed salt used in the chemical industry as a source of sodium chloride for manufacture of hydrochloric acid and some sodium compounds. In its natural state, it is used extremely in tannins hides, in fertilizer in stock feeds, in salting ice highway as weight killer, in addition to its being used as feeder. It's also used in preparation of food for many kinds, preservation of food of many kinds, preservation of butter, cheese, fish, and meat. Silverite, mode of occurrence and association are the same as highlight. Soluble potassium salt are used as fertilizer. Fluoride occurs in hydrothermal vents and replacement deposits, common in dolomites and limestone, as minor constituents in igneous rocks and pegmatite. Used as flux in making of steel, in manufacture of porcelain glass, in enhancing cooking utensils, and for preparation of hydrofluoric acid. Also for the construction of lenses and prisms. And then we have the atachanite, a major copper oil. For week 1 and week 2, these are the assignment we expect to undertake. With the aid of a map of natural states, we decide for each local government 3 minerals occurrence for each local government. Similarly, with the map of Nigeria to illustrate at least 5 minerals location per state. Now, classification of mineral based on oxide and hydrazite. Those ones are the copper art found in the limonite, copper, malachite, azurite, used as a major oil of copper. The second is corundum, the highest non-mineral next to them, used as an abrasive in making grinding wheels. Synthetic artificial corundum manufactured from bauxite is now more widely used for purposes of color varieties are used as gemstone, as watch rings, as bearings in scientific instruments. Pegmatite occurs as a product of volcanic activities, also found from the metamorphism of iron containing minerals like limonite, siderite, magnetite, and results from the replacement of limestone by the iron solutions of latic hematite. An important oil of iron. Earthly varieties used as peak grade, etched, and polishing powder, while the fine black crystals are used as semi-precious stone. Limonite occurs in basic igneous rocks, gravels, diorite, as a product of magnetic segregation, also in some pegmatite and bend deposits associated with magnetite. Rutile, apatite, is the most important source of titanium dioxide, which is used as pigment in rayon, artificial silk manufacture, and the ceramic industry. Also a major source of titanium used in the construction of aircraft and space vehicles because of its high strength to weight ratio. Rutile, sometimes with up to 3% of iron, found in granite, pegmatite, schist, metamorphosed limestone, and dolomite. Also has a slender inclusion in quartz and mica. With ilmenite, rutile is the most important ore of titanium, which is used in alloys for electrodes in arc lines. The oxide is used in peak pigment. Rutile itself is used as a coating of welding rods. Then the cassiterite belongs to this group. It It occurs in original contents of igneous rocks and common in high temperature hydrothermal vents or near granitic rocks. It's also found in pleasant alluvial deposit and stream tip. This is the only well-known tin oil. The material tin plate and plate for the production of cans and other food containers. It's used also in various alloys, for example, in the soldering, dairy metals, and bronze in that order. The class of minerals still continue on the axides. The seventh is the pearlite, most iron, important magnesite oil, and the lunite, which is radioactive, chief of uranium. Spenite used as gem when transparent and finely colored, for example, rupert spire. Magnetite as iron, 3 oxides, 4, form at high temperature in magmatic segregation of from metamorphism of other iron minerals. Forms large oil body, beds lenses. The largest lignite deposit in the world results from differentiation of basic magma. It's found in North Sweden and is valuable oil, iron for oil. The chromite is the only oil of chromite of which is used as ferroalloy to give steel the combined properties of high hardness, great toughness, and resistance to chemical attack. Chromium is also a major concept of the steel-like steel. The class 5 of mineral based on mineralogy is the carbonite, the nitrates, and the borite and the iodine. The first group here we have the calcite. It occurs as the most common forming rocks in limestone, marble, crystallized and metamorphized limestone, in chalk, calcareous marls, and calcareous sandstone. Also occurs as stalagmite and incrustation as travel in topaz in both coal and hot spring. Limestone is used as a building material, also mixed with clay for manufacture of paint. Pure varieties provide lime, used in many industry processes. For example, manufacture of bleach, powder, calcium carbide, glass, salt, pepper, paints, etc. Limestone and marble are used for construction purposes and exterior decoration. Iceland spark is used in the construction of optical apparatus. Nicholas. Then we have the magnesite dissolved in warm with HCl. Then we have the siderite, iron carbonate, and iron ore of iron, and then we have the spironolite and iron of zinc. The arrogance form the fourth part, occurs in association with the base of gypsum, with iron ore in forms of fluids or as deposit from water of hot spring in autolytic or precipitative forms. It is less stable than under atmospheric conditions in which it passes on application of heat and pressure. The strontiumite is the source of strontium. The cerite is an important ore of lead. Dolomite occurs in hydrothermal vent as sedimentary strata, and dolomite marble as metasomatic deposit in limestone, used as building ornament stone, also manufactured for certain cement, and used in refractory furnace linings, the source of carbon dioxide and metallic manganese. The malachite, found in oxidized zones of copper deposits associated with azurite, copperite, rarely as cementing material in sandstone, valuable oil of copper, also cut and polished, and used purpose for vases, mainly for tabletops. The azurite, found associated with the oxidized copper, belongs to this group. It's a copper mineral in the zones of weathered and inland deposit, also used in impregnation in sedimentary rocks. We have the sixth class is the sulfide. In the sulfide under this and the chromite tungsten, we have the andesite, of course, as salt or saline deposit associated with gypsum and rock salt through natural evaporation of seawater. It forms from gypsum in seawater at 25 degrees Celsius and altered to gypsum with an increased volume by hydration. Also occur in oil vents, used as fertilizer and as a settling retardant in cement. Also used in manufacture of plaster, sulfates and sulfuric acid. And the other group is the barite, which is sulfate of barium, strontium, and lead. In the barite, which is barium sulfate, occurs as ground mineral in hydrothermal associated with sulfide in fishes in sedimentary rocks, limestone and sandstone, and as nodules in clay and mud. Also deposited and sintered by water from hot spring. Used as chief source of barium, a major source of which is lithophile, used in paint industry, floor covering, textile. Most of the barite produced is used as drilling mud in oil and gas well drilling in support of drill roads and to prevent blowing out of gas. Also employed as filler in paper, cloth, cosmetic, as a paint pigment. Then the siltonite, used in preparation of strontium nitrate for fireworks and trace bullets, and other strontium salt used in refining of beet sugar. We have the hydrous sulfates, which are the gypsum, of course, in the silane residue evaporite, arising by evaporation of enclosed basin of seed water, whether product of sulfide, oxidation of barite resulting to the generation of hydrosulfur, which acts as calcium carbonate or and shales. Also in oil deposit in clays and shale, used as a retardant in cement, as a fertilizer, as a filter, in various materials such as paper, crayon, paint, rubber. It's a chief use in the manufacture of plaster Paris, of which purpose the mineral is ground and heated to 120 to 30 degrees, 130 degrees Celsius to express some of its water crystallization. Plaster of Paris, building thread, shells, board, mugs and casts, satin spare, alabaster are called and polished for this purpose. Then the alunite, this is also called alumstone and used in the production of alum. This The seventh is the class. The seventh class is the phosphate and arsenic and vanillins. Here we have the monazite, of course, associated mineral in acidic igneous rock, in pegmatites, commercially found in the terrestrial sand. In Nigeria, monazite forms a byproduct in the final grades of aluminum tin. It is the chief source of thorium oxide, which is used in manufacture of gas mantle, construction of missile lamp, and in medicine. Thorium metal is used in the production of iron, for example, with magnesium and electrical apparatus. It is radioactive and is a possible source of atomic energy. Monazite is also a source of sodium, which is used in air, in carbon and manufacturing glasses. Then we have the apatite. Of course, associated concerning magnetic rocks, cracks, and crystallized sheets in pegmatite, and then in veins in the sedimentary deposit. It uses is a chief source of phosphorus for production of phosphorus chemical. Transparent varieties of apatite, fine color, are used as gemstone, but the mineral is too soft for extensive use. We have other as the polyphenols, a subgroup of oil leaf, and then the vanillite, source of vanadium, and many oil of millets. The eighth classification, which is known for the 8th week, 3rd week, classification of minerals, silicate introduction, week 3. Silicates are the most important group of compounds occurring in the 8 crops. Together with the silicate groups, it make up 95% of the crops. They are mostly rock minerals or minerals from oxidized zones or veins or roots. They consist of a very large number, 25% of known minerals and nearly 40% of the common ones. And in most cases for isomic, continuous variant, all including quartz, contains the fundamental tetrahedral building unit in which the silicon atom is situated at the center of the tetrahedron, whose corners are occupied by 4 oxygen atoms. They are classified according to the atomic structure, and that's the way in which this silicon tetrahedral occur, and that's separately or linked together. On the basis we have the following, about 6 of them. Then the isosilicate, the sorosilicate, which have one silicon to have 4 group linked together, giving rise to Si2O7. The silicilicate, in which more than 2 tetrahedral are linked, forming ring structures of general composition, and then the rings of tetrahedron has a composition. The indosilicate, in which the tetrahedrons are joined together to form infinite single chains with unit composition. And then the phyllosilicate, in which 3 of the oxygen of the tetrahedron are shared between adjoining tetrahedrons, forming infinitely extended flat sheets of unit composition. Then the tetrasilicate, in which all the 4 atoms of the SO4 tetrahedron are shared by adjoining tetrahedron dimensional and with unit composition of silicon oxide. The ionic substitution is generally common and extensive between elements of similar atom radius and same radius with oxygen. The classes of mineralization, the 8 silicate silicate classes, this one belongs to the olivine group belongs to that. It gives the mineral a green color, occur essentially in mineral in periodized and basic igneous rocks such as olivine, gravel, basalt, and dorite. The rock mineral is made almost wholly of olivine, and the variety foster occurs metamorphic dolomite limestone. Attach very readily to tau, silvertite, magnetite, and iron oxide. The use is used as a precious stone. It contains nickel and gives rich nickel silicate. Iron-rich platinum containing varieties indicate platinum finding places. The aluminum silicate family occurs as andesite, similite, and kaolite, chemically similar to topaz and strorite, occur in metamorphic rock, mostly of adversarials and clayey composition. The form depends on the physical factor prevailing during the metamorphism. Then the andesite is found in metamorphic rocks, in microschists, gneiss, pegmatites at fairly high temperature and low stress, altered to most cobalt. The similites are high-grade metamorphism, all rich rocks, usually under high temperature and moderate stress. The kaolite metamorphism of iron-rich in quartz band, usually under high temperature. All these 3 minerals are used as index minerals in defining metamorphism as a function of temperature and pressure and temperature. For example, similar defined zones that have been subject to temperature of about 620 degrees Celsius and upward. The metamorphic zones are named after the index mineral present similarized zone. The continuation of the 8th class, the nicosilicates. In the nicosilicate class, we have the garnite. It's a silicate of various divalent and trivalent metals in the general formula, as stated here. These occur commonly in metamorphic rocks such as gneiss and schist of aggregation sedimentary percentage, in crystalline limestone and in metamorphosed basic and other igneous rock. Some variety occurs as primary rocks and igneous rocks, especially of the cementite family, also common in heavy sedimentary stream sediment. Altatite, sipotite, and chloride. It is used as an inexpensive gemstone, for example, in fine clay crystal of Bremen garnet, and then also used as abrasive, especially in the polishing of wood. Members of the groups are perovskite, andesite, and goswine. Then we have the zircon. The zirconium silicates occur as primary mineral of more acidic igneous rock, and will correspond to pigmatite forms also in the trentite deposits, for example, stream and bluestone. It's used as space crystal for gem and other zirconium metal, used in islands with iron, silicon, tungsten, and serve as a source of zircon. Used as a refractory in abrasive and also in blend ceramic. It's used to make textile impermeability. Then the topaz is an aluminium ferrosilicate, occurs in acidic igneous rock, also in tin-bearing pegmatites and in tin veins, generally associated with fluorite, cassiterite, and tourmaline used as gemstone. Then we have the spiralline calcium titasilicate, occurs associated mineral in igneous rock, in metamorphic limestone, used as a source of titanium, observed for as a paint pigment and also as a minor gemstone. There's silicate sorosilicate under the classes of that. We have the hemimorites hydroxide silicate, a secondary mineral found in oxidized zones of zinc deposit associated with sphalerite and cerussite and galena. Is used as a paint pigment, as a minor gemstone. The indocrest, which is a hydrosilicate of calcium, aluminum, and magnesium with some replacement of iron. It presents both SiO4 and SiO7 group, thus giving formula SCA, and then the magnesium ion, and then the aluminum and the silicate of that associate. It's a typical contact metamorphic rock minerals. The green variety, chalcophenite, is used in semi-precious stone. Then we have the epidiac group, which is a complex silicate with general formula as stated below. Then the zerosite, which occurs in the metamorphic rock and crystalline schists. And the iodide occurs in the metamorphic impure calcareous rocks and limestone ferrite igneous rocks, also in hydrothermal vents. The other class is the cytosilicate under the X. We have the barite, we have the tourmaline, and the chloride. The barite is various as emerald transparent deep green color, blue. And then it has a gold barite clean, gold yellow, aquamarine transparent, pearl greenish yellow, as occurs in granitic rocks and pigment. Also found in metamorphic rocks of various types. For example, mica schist associated with tin oil. Uses as barite, which is used in encampment in form of alloys with copper, iron, and nickel. Fine oils are emerald are used as gemstone. Tourmaline is a complex of borosilicate of aluminum together with the alkaline metal or iron and magnesium, also found in iron and other aldehydes. Occur in the typical monoclinic mineral in magmatic rocks and in their contact zone in schist, gneiss, also in heavy residue. In many sedimentary rock, uses color variety and beautiful ceramic gemstone. It is a strong isometric mineral and is therefore used in the manufacture of pressure gauges to measure transient blast pressure. The corundum is a silicate of aluminum, magnesium, and iron. Represent quartz and corundum occur as a magnetic mineral in diorite in the original metamorphic rock. The homing flames are glacial composition, commonly attached to form of mica, chloride, and tar in that nature. The clay of minerals in that the silicate under this group are linked by sharing two structural types, single and double chain, as illustrated. The orthorhombic pyrazite, these are two marked gradual in physical property as uniformity, both occur in basic and ultrabasic rocks, low in calcium, and then perodite gravel, literal basalt, also in some metamorphic rocks. The X of the indosilicate class, these ones have the algae, the silicate, the amphibolite group. They are all involved in that. And the human blend, their commercial uses are their commercial as asbestos, deposit of asbestos in the commercial sense, occurring in long fiber crystals. And they are very useful for such commercial purposes as asbestos. We have the mica family under this. The mica family occurs as cause of acid igneous rock, such as granite pegmatite. It is used in the electrical industry for isolating purposes in electrical apparatus. The group of mica is employed in production of roofing material to prevent the product from sinking to another. Also manufacture of lubricant, well finish, artificial stone, rubber tires, and to give close to water. Powder mica is used to give frost and snow effect on car and trees. Liquid light is an oil of lithium. It's also found under the mica family. The family includes muscovite, biotite, lepidolite, and also garnet. Muscovite is colorless, used as heat-proof window, stove, and lamp chimney. Lepidolite, which is the lithium mica, occurs in pegmatite, associated with tourmaline, topaz, and other minerals of magnetic origin. Used as a source of lithium and in manufacture of heat-resistant glass. The chloride family hydrosilicates of iron and aluminum and magnesium. The chloride variety includes the clinochloride, phenotite, and pidorite. The metal family, used as slabs from massive forms, soapstone, are employed for electric switchboards, sinks, lab and tabletops, acid tanks. The powder form is used in ingredients as paint, paper, rubber, plastic, lubricants, ceramics, and insecticide are also talcum powder, French chalk used by tailors for making clothes. The ciprotide used in building stone for ornamental work in general. Interior decoration, fiber variety supply a great proportion of the asbestos, and then the chloride and ciprotide are hydromagnesium silicates. Then we have the same A group, the silicate phyllosilicate class, which are the clay mineral hydroaluminum silicate. Here we have the kaolin, occur in hydrothermal alteration and weathering of feldspar, in clay and its late formations in vein, used for the manufacture of fiber concrete in China concrete, also in ingredient in paper, rubber, and pen manufacture. The monomerylite, which is replacing the part of the aluminum oxide, called swelling clay. Consider a large portion of clay bentonite. Bentonite is employed in the chlorine of oil, watering softening as a filter for taking of drilling mud and sinking oil wells, and as an solvent in many processes. The illatite has a structure intermediate between that of muscovite and that of non-mineralite. And then we have the pyrophyllite, which is a physical property similar to those mentioned above and is used for the same purpose. Then we have the silicate. Under the silicate, number 8 is the feldspar family. It's the most important group of rock-forming minerals and dominant component of the lithosphere, consisting 60 to 69% of most igneous rocks. They are androsilicates of calcium, sodium, calcium, and barium. Feldspar may be divided into the potash feldspar, barium feldspar, soda feldspar, and lime feldspar, plagioclase and feldspar. They are stable, thus occur in all states, generally occur in igneous rock. The alkaline feldspar characterizes the more acid rock. The lime feldspar, the more basic rock. The alkaline feldspar enter commonly into sideral mica, secondary mica, and possibly into kaolin. The lime feldspar into sodular mix of amber. The feldspar are used in large quantities for the manufacture of concrete, also manufacture of glass to contribute to the aluminum. The other class is silicate certificates, the first partout family and uses. Except for lazurite, they are all primary constants of igneous rock and follows the characteristic of the chemical composition. Quartz mica content. They are primary quartz and feldspar never occurs together in the same rock. If free silica had been present in the magma, it would have combined with the feldspar to form feldspar. Furthermore, this deficiency of silica restricts the occurrence of feldspar, except lazurite, to igneous rock. Low in silica, rich in alkaline, such rocks are nepheline and leucite, siderite, and phonolite. And they are also the leucite basalt and so on. The leucite is used for production of potassium, feldspar, and aluminum. And then we have decay always present in the nepheline artificial sodium. It's used in place of feldspar in manufacture of glass, also employed in ceramics, leather, textile, and industry. The silica group, of course, have the purest and most transparent form of quartz are employed in jewelry and making spectral glasses. Amethyst, rose quartz, Caron, smooth quartz, milky quartz. They all belong to this group. And there are beautiful varieties like amethyst, rosy quartz. They are used as ornaments. And sometimes they are employed in mold and glass making of silica brick, abrasive material as it's also sandpaper, toothpaste, and propane. Sandstone is used in the building trade. Scientific uses include making of lenses, optical instruments, transparent crystal being cut into quartz wedges, used as a microscope depending on the piezoelectric properties. It is cut into small oriented plates and used with shockwave radio apparatus to control the frequency of radio cycle. The same property applied to thin quartz plate used in digital quartz watches. The other telesilicate, which is still part of the family, is the crystalline silica. They are fibrous and granular in variety. Fibrous variety. We have the chalcedonite, the agate with alternating layers of chalcedonite, having different colors and porosity, cut and polished from bronzes, snub and boxes. Granular variety like jasper and flea and cherry are also useful. They are used for precious opal, gem variety, exhibiting brilliant clay of colors, hydrophone, hydrogen, silica, wood, opal, and diatomite. Diatomite is used as absorbent and as a polishing powder, filtration powder, and insulation powder. The zoyline hydrated silica of calcium, sometimes sodium. Many ways of anodons in composition to the first one. Now, this gives us an overview of the description and then an overview of mineral resources distribution in Nigeria. This map shows all the states of the nation and then the minerals that are present in every country. This table is classified Nigerian mineral environment. It's just the metallic minerals, the industrial minerals, the energy minerals, the precious stone, and construction minerals. These are minerals that are available in Nigeria in this category. The metallic, you see the gold, the tantalite, which we've talked about, the industrial, the clay, limestone, marble, gemstone, the pedolite, diatomite, talc, and the rest under that. For the energy and minerals, we have coal, bitumen, lignite, and for the precious stone, marine, topaz, garnet, zircon. And then we have the construction material, which are the granite, gravel, sand, clay, water, and of course, water from that. Before we'll be looking at the origin of mineral resources. Mineral deposits may occur independently forming layers and bodies of different shape, extending millimeters, kilometers in area extent. In some cases, mineral may be present in inclusive rock, all country rock, or host rock. The origin of mineral resources can also be seen on the basis of time and formation relative to the host country rock. On the basis, deposit can be divided into two, namely the synergetic deposit and the epigenic deposit. The synergetic deposits are formed simultaneously with the host rock together. The epigenic deposits are those formed subsequently or later events to the formation of the host and country rock. Secondly, we can also classify mineral deposits based on primary and secondary processes. Primary deposit or hypogenic. These are deposits that are originally formed relative to the host rock. Secondary deposits are supergenic. They constitute alteration product of the primary deposit, either through weathering or associated processes. The brief origin of minerals is based on geological setting of geological environment. Deposits of economic valuable minerals are formed in a variety of geological settings of geological environment, where they are formed as follows: the igneous mineral deposit, hydrothermal mineral deposit, the plate tectonic boundary deposit, the sedimentary oil deposit, the stream and weathering oil deposit, and then the metamorphic oil deposits. The origin of mineral resources, that is the geological setting of this, the igneous oil deposit, as we mentioned, they are formed from magma, then cooled below the surface and contain a variety of ore, platinum, gold, silver. As the magma cools, it can concentrate minerals after they have crystallized. Lighter minerals will rise to the top of the magma chamber while the heavy minerals will sink to the bottom of the chamber. For example, chromite. Igneous oil deposit may be especially valuable if the rocks are coarse grained, especially in typical rock forming minerals are found in pegmatites such as feldspar, quartz, and mica. Minerals formed may include gemstones such as beryllium, aquamarine, tourmaline, rubin, and emerald. Hydrothermal mineral deposits. Magma have water and other fluids dissolved or associated with them. During the latter stage of crystallization, the fluid may escape from the cooling magma chamber by seeping through cracks and pore spaces in the surrounding rock. These fluids carry with them dissolved salt, gases, metal. These warm fluids can also leach additional metal from the metals from the rock, through which pass in time and with fluid cools and deposit their dissolved mineral, creating a hydrothermal oil deposit, which are observed as veins, cotton, through some country rock. Many metals are found in minor oil deposits. For example, copper, lead, silver, gold, platinum, zinc, uranium, etc. Then the plate tectonics. Plate tectonics plays a major role in creating oil deposits. There's a relationship between magmatic and magnetic activities and the formation of oil deposits. The type of activities that occurs along the plate boundaries and precious metals are deposited. These are predominantly where minerals are deposited to the magmatic activity associated with plate collusion and subduction zones. Now, for the metamorphic oil deposit, there are mineralogical changes caused by heat and pressure due to metamorphism can also produce economic mineral deposits such as graphite and marble. The sedimentary mineral deposits, these are typically created by chemical composition. Limestone and dolomite are typical examples of sedimentary rock deposits. Others are evaporite formed when the body of sea water trapped in a shallow sea or lagoon dries up, evaporate. For example, gypsum and halite. Banded iron deposits are also examples of sedimentary iron deposits, constitute the largest source of iron on the earth. The structure consists of the chert. The deposit can run from tens of kilometers and some in a very large places on the earth and restricted to old sedimentary rocks, very old in age. Their formation is thought to be related to the development of the earth atmosphere, where the early earth did not have oxygen in its atmosphere, therefore no iron could weather into iron oxide. Then we have the banded iron ore in Nigeria. This occurs generally in Nigeria in metamorphic folded bands associated with the Precambrian basement complex rocks, which include low-grade metamucilin, high-grade schists, gneisses, and mid-metal. Examples are Lokoja, Okene, District Network Itake, Abadina, Chokotoko, Totomoro, and Tijani. In the northwest of part of Nigeria, the BIF occurs sporadically in narrow bands and lenses interbedded with polyp and semi-polyp ferrite and schists. In Beniguari area, they are embedded with granite quartz, mica schists, lenticular bodies of quartz, and carbonaceous cysts. While in the Moro area, they are interbedded with massive green pyrite, heavily developed stepping rock, plastic micaceous material, amphibolites, and varying in thickness. The stream and weathering deposit. Weathering can concentrate mineral deposit. Weathering can also control oils by leaching away unwanted material, leaving a residue rich with metals value. For instance, the bauxite is created when laterite soil are heavily leached by rainfall, leaving behind insoluble aluminum minerals. Minerals weathered out of rocks can be carried as sediments and pushed along the stream bed. And the weather-resistant minerals such as gold, diamond will concentrate in stream bed. Such concentration by water are called as pleasant deposits. The Nigerian geologic environment and mineral resources will due to three basic environments. The basement complex. The minerals associated with those rocks are marble, banded iron, and useful materials for construction purposes. Ironstone, gold, manganese, marble. Some are related to late-stage pigmatite content gemstone, followed by tantalite and other specialty metals and cassiterite. The longer granite, the mineral resources associated with them include oil, lead, zinc, tin, niobium, titanium, copper, uranium, chromium, gemstones, and construction materials. The sedimentary basin, the mineral resources common here, the crude oil, natural gas, coal, lignite, bitumen, lead, zinc, copper, barite, gypsum, limestone, clay, bitumen, brain, phosphate, chloride, ironstone, gravel, and glass sand are common in this environment. With 5, we look at the fossilized forests formed by natural process of aerobic deposition of very dead organisms. They contain high percentage of carbon. This includes coal, petroleum, and natural gas. Coal, oil, and natural gas were formed hundreds of millions of years ago during the Carboniferous period before the time of dinosaurs. Hence, the term fossil fuel. The age they were formed is term Carboniferous period between 360 to 236 million years ago. It's the part of the Paleozoic and the Carboniferous that give rise to the carbon. The carbon basic element is coal and fossil fuel. During the Carboniferous period, the land was covered with swamp, filled with huge trees and other large leafy plants. As the trees plant died, they sank to the bottom of swamp, of oceans, and formed layers of spongy materials called peat. Over many hundred years, the peat was covered by sand, clay, and other minerals matter, which turned into rocks, with more and more being formed and wetted, and then pressed down on the peat and continued to be squeezed until water come out of it. Eventually, over millions of years, they turn into gold, oil, or natural gases. Coal, the term coal generally applied to sedimentary formation, highly carboniferous in character, as derived from vegetable matter involved in a series of processes such as burial and biochemical transportation. Coal is very black colored rock like substance. It's made of about 60 to 90% carbon, 2 to 20% hydrogen, 1 to 12% oxygen, and nitrogen 1 to 3% nitrogen, and an invariant amount of sulfur and phosphorus. Coal may contain very proportional mineral matter, which means the residual mineral content of the plant from which the coal was derived or derived in origin. We have 5 types of coal, namely andesite, bitumen, sulfur, lignite, and peat. Andesite is the highest form and has more carbon, therefore give its high energy content. Lignite is the softest, hence low carbon, but hydrogen and oxygen. Bituminous and sulfur are therefore in between the highest and the lowest. So in classifying coal, geological processes apply pressure to the battery material over time. Millions of years. Under the cyclic control, this gives rise to these ones that are transformed. Peat is the lowest, followed by lignite, so bituminous, steam, and then the anthracite, forming in that pattern. So the classification and description of coal, the peat is considered to be the prescon of coal. Industrially, it's used for fuel in regions like Ireland, Finland, and other Western world. In its hydrated form, peat is highly effective as a bond of fuel or oil spills on land and water. It is used as a conditioner for soil to make it more able to retain and slowly release water. Lignite or brown coal, this is the lowest rank coal, which is used almost extensively in fuel for electric power generation. Jet, which is a compact form of lignite, is sometimes polished and used as ornamental stone. The subbitumen coal has property ranging from lignite to those of bitumen coal. Its primary use is for fuel steam, electric power generation, and it's also an important source of light aromatic hydrocarbons for chemical synthesis industry. Bitumen coal, this is a dense sedimentary rock, usually black in color, but sometimes dark brown, often with well-defined browns or bright and dull material. Its primary use is fuel and steam electric power generation, also used for heat and power application manufacturing to make coal. Steam coal. This is a grade between bituminous coal and andesite. It was used widely as fuel for locomotives, used as fuel for domestic water heating. Andesite is the highest rank of coal. It is hardly glossy black coal, used for residual and commercial space heating. However, there's a footnote under this. Sometimes people consider graphite as coal, and it's technically the highest rank coal, as we call it. It is difficult to ignite, hence it is not commonly used as fuel. It is mostly used in pencil, and when powered down, it can be used as a lubricant. However, I prefer to treat this under the native. The graphite on this course is treated under native, as earlier on stated. Graphite C, Muscat graphite deposits are final products of deep-seated organic material, also occurring in veins, igneous rock, needs crystalline limestone, and is used as a battery crucible for steel, brass, and bronze industry. Mixed with oil, it is used as lubricant and forms lead of pencil, also employed in manufacture of protective paint for structural steel and used for battery, electrodes, generator process, and electronics. So it is termed, it does not categorically belong under the coal group. It stands under the native element. Coal in Nigeria. Coal was discovered in 1909. Operating drill mines operated 6 years later. Other mines were subsequently discovered operated. These were merged to the Nigerian Corporation, Coal Corporation, NCC, in 1960. The NCC was tasked with exploiting coal resources and had a monopoly in coal mining and coke mining, making, and production of slave until 1999. Nigeria is still blessed with large coal reserve, which is roughly estimated to be about 2 billion tons. Some of the coal fields mined in Nigeria include the following: Ezemo Iron Fields, Oberoti Mines, Obete Mines, Oyama Mines are all in the Enugu State. Others are one of the 2 Okwaba coal fields, all in Kogi State, Agwashi, Kazaba, Lignite Field in Delta State, Oyama Mines in Anambra State, Owaka Mines in Benue State, and there will be like Lafia, Kiana coal fields in Nasarawa State, Ribadu Mines in Adama, Medaga Mines in Kogi. Petroleum is derived from the Greek word petra, which means rock, and the Latin word omen, which means oil. Petroleum is naturally occurring yellow to black liquid found in geologic formation beneath the Earth's surface, which is commonly refined into various types of fuel. It consists of complex mixture of hydrocarbons of various molecular weight and other lipid organic compounds entrapped within the rocks of the Earth. The term petroleum covers both naturally unprocessed crude oil and the refined product. As well, fossil fuel, petroleum is formed with large quantity of dead organisms, usually zooplanktons and algae, and buried underneath sedimentary rocks and subjected to intense heat. Chemically, it is composed of a mixture of carbon hydrocarbon, mainly paraffin, methane, ethane, propane, and butane, naphthalene series, and aromatic hydrocarbon. Apart from hydrocarbons, small quantities of compound of sulfur and oxygen are also present in varying amounts. In some cases, trace of metallic elements like vanadium and nickel are also found. Formation of petroleum is a fossil fuel derived from ancient fossil organic materials such as salt and iron. Vast quantities of this remain settled to the sea or lead water. Intense heat and pressure built up in the lower region. This process causes organic matter to change first into a waxy material known as kerosene, which is found in various oil shale around the world, and then the gaseous hydrocarbon through a process known as catalysis. Formation of it occurs from hydrocarbon processes in a variety of many interthermic reactions with temperature and pressure. The natural gas is a fossil form when the layers of buried plants and animals are eaten with heat and pressure over thousands of years. The energy that plants originally obtained is stored in the form of chemical bonds and natural gas. Natural gas is not renewable resources because it cannot be replaced in human time frame. It's a hydrocarbon gas mixture consisting of primarily of methane, but commonly include various amount of other alkalines and even lesser percentage of carbon dioxide. Nitrogen, hydrogen sulfur as a source of energy is often used for heating, cooking, and electricity generation. It's also used for fuel vehicles and as chemical feedstock in the manufacture of plastic chemicals. Natural gas is found in deep underground rock formation or associated with other hydrocarbon reservoirs and coal beds. And as methane clothes threads, petrol is found in proximity to and with natural gas. Most natural gas are created over time by three mechanisms, either biogenetic or thermogenetic. Biogenetic gas therefore means created by metagenetic organisms in matches in bulk and land and shallow sediment. Thermogenetic simply means it's formed deeper in the earth by high temperature and pressure, very other organic materials or materials under that. The story of petroleum industry in Nigeria, oil was discovered after 23 exploration in 1956 in the Olobiri in Niger Delta. The discovery was made by Shell BP, which at that time were the sole owner. Nigeria joined ranks of oil producer in 1958 by producing 5,100 barrels per day. After the independence in 1960, exploration work of oil was then opened to other foreign companies. These were somehow affected by Nigerian Civil War, while by 1990, the Nigerian Civil War, or the Biafran War, ended concerning with the rise in the oil price. Nigeria then joined the Organization of Petroleum Exporting Countries, OPEC, in 1971. Nigeria further, more in 1970, established Nigeria Petroleum Company NNPC. By 60 and 70, were producing over 2 million barrels of crude oil per day and millions per day. Then, now we do not know about all of that. The other topic, which is called 6, is the surface and underground water. When we look at this hydraulic, some call it hydraulic, hydrologic, and hydrologic cycle. For geology, we prefer hydrologic cycle. For engineers, civil, we use hydraulic for water. It tells us how the water on the earth, the whole world works from precipitation down to the bedrock, infiltration, runoff, transpiration, back to the sea ocean, and then evaporated back. It's a cycle, and the cycle is like a chicken and egg, which one comes first. But the hydrologic circulation of water in the environment. Hydrogeology examines the relationship of the geologic materials in the flowing water. Like we mentioned earlier, we found out that some of these water also perform similar role in mineral exploration, in mineral formation, and also help in guide in mineral exploration. The two, hydrology and hydrogeology, are interrelated and are interwoven. The two are inseparable. For example, groundwater hydrology and contamination transfer, hydrothermal deposit and their interaction with water, interaction with mineral formation, interaction as it affects our water resources, both the surface and groundwater, as it relates to geological, mining, agricultural, and mineral processing, and other human activities that affect this cycle. In one way or the other, it has significant contribution to the global climate change and the climate change crisis that we're having today in Nigeria. Of all the earth, water moves endlessly through the hydrologic cycle. In other words, you and I can drink the same water that dinosaurs drank 65 million years ago. The hydrologic cycle is a closed cycle system that has no beginning and no end, like the rock cycle or the case of chicken and egg, like I said earlier. The solar system, the solar energy hits the earth's surface, water in the lakes and streams evaporate, becomes a gas. The plant releases vapor too, and hence the term evapotranspiration. In other words, combination of evaporation and transpiration from the plant. When the vapor hits the cool air of the upper atmosphere, it condenses back to liquid water, forms cloud. When the conditions are right, favorable, rains or other forms of this falls to the ground. The precipitated water hits the ground where it will enter the flow force. The surface evaporates, seep into the ground, filtration, population, and into the water system. And the cycle continues on and on. So virtually, the hydraulic cycle is very, very important, even though human activities are affected. And like we have earlier defined, you have the transpiration, evaporation, precipitation, filtration, water flow, overflow, and stream flow. Evaporation from water bodies, water sources, and all of that. They run off, and that also contribute to this. That takes us about mineral resources in perspective. The next content, which is week 7, has to do with mineral processing perspective. In that, we have about 5 or 10 topics to look at. It's very, very critical because having this mineral, I don't add value to them, doesn't make sense at all. And so it's very critical. We already defined what the mineral is. Processing refers to transforming the run of oil from the mine to the grade that is required by the consumer to satisfy both economic and technical needs. The GAN is the unwanted mineral or waste residual mineral that has to be separated to remove them to have the consumption. Therefore, mineral processing can be expressed as a chain of operation designed to systematically add value to the crude oil that we have, that are mined, and to make it marketable. That is, we send the marketable end product to the market. That is what mineral processing is. Of course, mineral processing has a relationship with others. In the field of mineral resources, it's grouped under 3. Geology, geological engineering basically deals with the prospecting and exploration. Mine engineering deals with the winning of the deposit. Mineral processing or minerals engineering deals with the value addition. However, these are interwoven and intertwined, that each is related or depend on the other. The other aspect is really metallurgical, which refers to the sense of metal. Hence, the case of metallic or extractive metallurgy is applied to extract metal from the ore, and that branch of metallurgy are used to produce complete metal component for our industrial uses. Classification of minerals in terms of mineral processing based on metallic, non-metallic gemstones. The major criteria for material to either of two depends on the composition and on the economic substance it is one. Classification of minerals is based on the engineering perspective. Metallic minerals, which is measures on non-metallic. Another example I will talk about was gemstone. So in mineral processing, we classify them in this perspective. That takes us to what we call the oil, ore, and product handling. Ore refers to the mineral resource that can be exploited at prevailing condition profitably. In other words, how is the defense mineral that can be exploited? Well, oil product handling refers to the various units that a particular mineral has to undergo in the course of preparation, upgrading the mineral in the processing plant or the mineral processing plant to have value addition. And oil handling involves transporting from the mine where you're mining the material from the mine surface, either using truck or conveyor belts, and then you take it to the mineral processing where you do complete sampling, assay, and then taking the process. Sampling in mineral processing simply means an act of obtaining a small representative portion of the large or bulk material that fully contain the character of the original material. Assay refers to the analytical process to obtain the grade value, the metal content of the oil. This qualifies the material, whether it is worth it or not. Then sorting. These are original construction processes that have probably been used by early metal workers 1,000 years ago. It involves a preserve of individual oil particles and the rejection of those particles that do not warrant further treatment. In sorting, we have basic hand sorting, manual sorting, automatic and mechanical sorting. The process depends on the size, color, and other physical properties of the minerals. Manual sorting is not as hand sorting, it's manually sorted out according to size, color, and then the trapped metals among them are removed. Large pieces of timber that were broken on the run of mine are removed. The metal has drastically declined in application, but still useful, particularly for those who are mining gemstones and other precious stones. Most sorting is by hand. Electronic sorting can be applied to pre-concentration to reduce barren wasting in uranium, gold, and oil sorting, or to the production of final products such as limestone or diamond sorting. The material property is what electronic sorting uses the alternatives of the visible light, like the magnesite limestone and the base metal and gold metals, and then ultraviolet for magnesium ion, conductivity for sulfide, and X-ray luminescence for diamond. Photo Matrix sorting is mechanized form of hand sorting, but has laser light sensitivity. The sensitive photo multiplier is used to scan the system to detect the reflex surfaces of those rocks that pass through that sorting field. Sampling and assay is very, very important in mineral processing. Sampling refers to the process of obtaining small portion as assay, on the other hand, implies the action of obtaining information on the constituents and composition of the sample of ore and their various percentage. That takes us to combination. Combination is defined as a process of, because the mineral coming from the run of lead are big, so you reduce the sizes, you crush and grind for the purpose of breaking the interlocking between the minerals, what we call liberation, for concentration purposes, or produce aggregate stones in quarry as it is used for road construction. Because most minerals are finely disseminated and intimately associated with the raw or the gangue, they must be locked or unlocked or liberated. In other words, you must take them off. And combination is the way that we can achieve that by particles and oil reduction until the clean particles of mineral can be separated as valuable. Combination is the early stage that is carried out in mineral processing in order to handle fresh extracted material. Sometimes they bring from conveyors and all of those. And in the case of quarry to produce control aggregate. Combination mineral processing or mill takes a sequence of crushing and grinding. Crushing reduces the particle size of the ROM such a level that grinding can be carried out until the mineral and the gangues are substantially produced or separated. That is where it is. Crushing is accomplished by compression of oil deposit, reduced surface and impact, while grinding is accompanied by abrasion and impact of the oil deposit, as we see shortly that. Crushing normally is a dry process and is performed in several stages to reduce into ratio between small stages. The reduction ratio of crushing stage can be defined by the ratio of maximum particle size entering into the maximum, and then the particles are leaving that same crusher. Other definitions are available, like we use the tumbling balls, raw balls to also grow. There are various materials that are used for that. The principle of combination, mostly because minerals are crystal material and they have atoms are regularly arranged in three-dimensional array. The configuration of this atom depends on the size and type of physical and chemical boundary, holding them together. In the crystal lattice of minerals, these interatomic bonds are effective only small distances and can be broken if extended by tensile stresses. Such tensile stresses may be generated by tensile or compression forces. This is a typical example of pulling out on a particular mineral. Right? This is similar. And then you have this, there's a compressor, there's a contraction, as you see in the diagram, showing that. So crushing is undertaken primary crushing either underground or in mineral processing. Secondary crushing comprises of all operation returning the product to the primary stage and between 0.5 cm to 2 cm. Tertiary crushing may be applied in case of tough and very slippery oil material. These are typical examples of machine of crushing. The primary crusher, the jaw crusher, this involves two plates which open and close like a Roman jaw. So it crushes the mineral. You can see the blade, you can see the jaw, and the glassing crusher as shown in the example. This is a gyratory crusher. This is how it works, and that's the glove. So the secondary crusher, in secondary crusher we have the corn crusher, the roll crusher, and the hammer crusher. The corn crusher is a typical example of corn crusher. The grinding is the last stage of combination. It's performed through tumbling mills like ball mills, roll mills, or turbine mills. As opposed to crushing, grinding is subject to the law of probability. It depends on the probability of the ore entering the zone between the medium and the shape and the occurrence that takes place after entering. So it's very, very important. Grinding mechanism is demonstrated here. We have either impact or compression due to forces applied almost normally to the particle surface, or chipping due to uplink forces, and pressure due to forces acting parallel to the surface. As you see in the 1, 2, and 3. Sieve analysis for weakness. This is classification of materials according to their sizes, and it's of fundamental importance in mineral processing. It's used to determine one, efficiency of size reduction process, establish the necessary degree of liberation as attained in combination state, and then the optimal size of the feed to process is maintained, and then the size of which losses occur in concentration. The testing of sieving. Method of sieving crush on grounds of shaking them on a suitable screen surface. a known quantity of oil is shaken in a series of screens according to a certain prescribed technique. The material is shaken in the nest of sieves and resulting in either oversize or undersize. This is a typical case of a sieve that you sieve it, and then after doing that, you do your size analysis. These testing results are usually calculated, expressed in percentage, and or graphically plotted, showing the distribution of the particles. The minus sign indicates oversize. The plus sign means indicates oversize. The choice of sieves are very, very important. Sieves are chosen to make sure that the quasars do not retain more than 10 to 5% and not more than 5% passing findings in that relationship adequate. Now, after that, this is a typical table of the sieve plot analysis. That if you do that, this is what it is. And then this is a typical graph of the sieve analysis to show that, and that will show which part of the grinding per material are you taking for your concentration or for your further mineral processing, because we have reduced the size. Then that takes us to week 11, the concentration topic. Concentration simply serve that to separate the liberated mineral from those other physical properties by differentiating. So the process of collecting valuable minerals from associated ground and enriching that portion is known as concentration. The objective of mineral processing in anything, regardless of the method, is always the same: is to separate minerals into two or more products with valuable minerals as concentrate and the tailings or the lump particles in the minerals. Such separation, of course, is never perfect anyway, so that much of the minerals may produce, and then you have to retrieve them or in between of that. In such cases, fine liberation particles often lead to mingling within the tailing if you overgrind. That's why it's very important in your crushing and grinding. Grinding and crushing consume a lot of energy in mineral processing. And if you don't grind, if you overgrind, you have problem. If you undergrind, you have problem. So you must be precise to get what you find. And then once you have done that, the concentration process in mineral processing basically are developed into main types: the gravity concentration, flow flotation, and magnetic and electromagnetic separation. The gravity concentration, the principle is very simple. The method is used to treat variety of minerals, ranging from heavy sulfide to galena to coal, in that range, below 50 micron. It's used to recover residual mineral heavy deposit. In flotation, tailings are being increasingly used so that you remove mineral from this route. The principle of concentration is very simple. It makes us with different specific gravity by their relative movement in response to gravity and one or two forces. The latter often being resistant to motion, often by viscous fluid as water or air. It's essential for effective separation to mark density difference between the mineral and the ground. Some idea of this type of separation possible can be gained from the concentration criterion, which is DH minus DF all over DL minus D2, where DH is specific gravity of the heavy minerals, DF is specific gravity of the fluid medium, and then DL is the specific gravity of the lighter minerals. The criteria for concentration are: one, the relative density, the particle size, degree of repression, and the particle shape. Gravity concentration based on differences in density includes things like dense heavy medium separation, jigging table, sluicing, the gravity constraints. These are basically involved between these fractions, and then we have different density that can be separated with greater. The grains have different density, and so you can easily separate them either in classifier. The heavier specific gravity, the higher mineral fraction to that of the fluid, the greater is the ratio of relative gravities. And the more obvious is the choice of the measure concentration. So the heavy medium density is used for coal. You can separate for coal and mineral. They have the circular for fine grains. We have panning, we have jigging, and juice and formula furring and shaking table. As far as this as basic as mineral and basic integration of mineral processing, this is just for it. In the latter part, the heavier part of this will be later discussed in the other part. The last week, which is week 14, we're looking at how is mineral processing happening in Nigeria. One, there's no technical level of lack of investment capital and lack of incentive for the mineral. Lack of higher recovery, the copper extraction equipment sometimes are crude, difficult to changes of technology being conservative, only if it's increased, and most processing are best hand sorting, that's the huge time, And therefore, most of our minerals in this country are taken out and processed. And that is not good for our economy. For example, I've tried to look at one good example, the gold processing. Gold for Arias Quartz banks for several hundred dollars per ton. It's crushed down to pebbles manually with hammer in some communities. We use jaw crusher, which has many advantages over manual handling. The grinding and milling using ball or roll mills, either wet or dry. The former is preferable. They use two varieties of type, however, not very efficient. Now, the gold processing by small scale miners, the aggregation method, gold is dissolved in mercury, being in use for years. That is dangerous. It's not supposed to. In fact, it's globally now, if your gold has any percentage of mercury, nobody will buy from you. So it's easy to learn and carry, but it does not require investment equipment. It's no recovery. There's toxicity, there's environmental hazard, and mankind hazard. So that method is not allowed, it's not supposed to be allowed. The standard method is recover gold from tailing, keep thick, not labor intensive, toxicity short-lived, highly toxic, and requires utmost care. It requires substantial investment and difficult to transport, and not really available in rural areas. The boron method is the best method, so we suggest that the local miners should use the boron method. It is simple, it is easy, and expensive. It's a chemical that occurs in nature as evaporite deposit. It does not require investment in equipment. High gold recovery is feasible as powder, as easy to transport, environmental friendly, and cheap than mercury used by gold dealers. Local content, the Nigerian situation, beneficiation constraint, lack of alternative mineral melting plant for both local and consumption and export purposes. We need to encourage PPP participation in mineral processing, encourage the siting of mineral processing and smelting plants in the state for specific minerals after careful research and development R&D, and systematic mining of minerals and areas of competing advantage. Local tension issues as practice in the oil sector should be applied to the mining sector. Attract private investment and expand value addition in downstream sector and industry. Accelerated growth, export value mineral and electric product. Total realization and practical development of our mineral product is very, very important. Thank you. Thank you. So where is the guy? I think okay, then it's one. Anyone finished it?
You want to continue?
No, I finished.
Okay.
That's all. What do you
yi zo ya sha tare shi yana ba shi ya maka.
Zo da nake a can nan ba. Ya ji kana ba.
Ya ji na ta kokarin yi. Ai ka taimake shi ya yi.
In ka gama wannan ɗin sai ka je ka yi koya a can ka ci sau da
Nan ne kamata ya zo.
Zuwa za ka zo jami'a.
Ya gobe. Yanzu kuma. Hello?
Ina kan mai harin da mu gane kan
Lafiya da fito. Ina zamu yi wa.
An gamsa.
Yanzu zan kira ta